Let's complete the square, a visual representation, part 2. In the earlier video, we have learned how to complete the square of a given quadratic expression in which we restricted the coefficient of x to be positive. For example, when given x squared plus 4x minus 3, we're able to represent each term as an area. X squared is represented in the form of a square with length x, 4x is split into two equal rectangles of 2x each, and minus 3 as 3 negative ones. We form an incomplete square using x squared and 4x and figure that the remaining area required to complete the square is 2 to the power of 2. Hence, we add in a zero pair of 2 squared so that we can complete the square of side x plus 2. Now this results in the extra areas of negative 2 squared and negative 3. Algebraically, we have added 2 squared and deducted 2 squared from the expression, whereby the first 3 terms form a perfect square. We then simplify the remaining terms outside of the perfect square, giving us a new expression, x plus 2 squared minus 7. How about x squared minus 4x minus 3? Well, we first start off by representing x squared and minus 3 as areas. Now let us take a look at the square. We can partition the lengths to become x minus 2 and 2. Now why we do this is because we intend to deduct 4x away from the blue square. We can let the first 2x be the vertical rectangle, then the second 2x be the horizontal rectangle. The problem then comes as we have made a double deduction on this square. We then use the idea of a zero pair so that we can sort of compensate the area being deducted. The resultant square would then be x minus 2 squared. Hence, algebraically, what's done is the addition of 2 squared minus 2 squared into the expression, where the first 3 terms form the perfect square and the remaining terms are simplified, hence giving us x minus 2 squared minus 7. Of course, we could have used the same concept of the positive coefficient of x to do this, but it may not be very intuitive for many. We can represent negative 4x as two negative 2x rectangles of sides x and negative 2. The missing area in the bottom right corner would then be the square of negative 2, which is positive 4. We then add the zero pair into the expression to complete the square and simplify what's remaining. Algebraically, this works out to be somewhat similar. Adding a zero pair of negative 2 squared, group the first 3 terms to form the perfect square and evaluate the remaining. We can generalize this for any positive real coefficient b and any constant term c to give us the same result. Now pay close attention to the algebraic expressions below. The expression on the left can still be simplified further. Notice that minus b over 2 squared will always be positive as any negative number when squared becomes positive. As such, we can safely drop the negative sign in the squared function, hence giving us the same expression on the right. In summary, if you have seen the two videos consecutively, you'd have learned how to complete the square, be it when the coefficient of x is positive or negative. Now, given these two different formulae, we soon realize that we can generalize it into one formula, where b and c can be any real number. And with that, this concludes on how to complete the square. Till we see you again in the next video, don't forget to like and subscribe.